Hey everyone, welcome to dotnetFlix. Today we're going to talk about Pulumi, and that's an infra as code tool that you can use to deploy resources. And here to talk about that is Sander, my colleague Sander. Can you tell us a little bit about Pulumi?
Yeah, sure. So as you said, Pulumi is an infrastructure as code tool, right? So for those who are unfamiliar with that term, infrastructure as code simply means that you use a script or a program to deploy your resources programmatically. So let's say I want to deploy some resource to Azure. Let's not go to the portal and do everything manual, but let's create a program that does that for me, right? And the main benefit of that is it's repeatable. So,
Hmm.
every time you want to change your environment, I give a lot of talks on conferences. So I always use infrastructure as code for my presentations. And then if I'm done with a talk, I can destroy my environment. And if I need to redeliver that talk 2 months later, I can simply run that script again. And there are all my resources again.
Yeah.
And yeah, so Pulumi is one of the ways, one of the tools you can use to do that.
Yeah, and that's comparable to, let's say, Bicep or Azure Resource Manager or Terraform. Is that the same category of tools?
Yeah, it's the same category of tools. So
Okay.
actually, I started out with Bicep and ARM for one of the presentations I did.
Hmm.
But I ran into some issues there where Pulumi could help me solve those issues.
Okay.
So let me just switch to my slides and tell you a little bit about that talk I did.
Yeah, let's do that.
So earlier this year, I had the opportunity to present a session on Azure Container Apps at NDC London, and that included some live demos. So, because I was using Azure, I wrote some Bicep modules to deploy the infrastructure for my demos. And I really like Bicep. I think it's much better than using ARM templates directly. So, my resources were deploying just fine, but then it was time for my last demo. And in that demo, I show how to use the easy auth feature of Azure Container Apps. And that requires you to set up an application registration in Azure Active Directory. And unfortunately, Bicep doesn't support that. And that's reasonable because Bicep simply deploys ARM templates, and those ARM templates only support Azure resources. So I cannot use Bicep to configure anything else outside of Azure, such as Azure AD. At least not at the moment. There are some rumors that maybe it will happen in the future, so that would be very nice. But for now, I was pretty much stuck. So I need to work around, and I ended up with both Bicep modules and some PowerShell scripts to configure the Azure AD part. So this combination has its own problem. For example, you cannot really get the client secret of an application registration after it has been created. So, the second time I deploy this whole solution, I also need to get a hold of that client secret because it is one of the input variables for the Bicep module. So one of the workarounds to simply reset that client secret every time. That's not ideal because in a real production scenario, that would mean I would have some downtime. Another workaround would be to store it somewhere and then reuse it the second time. But of course, client secrets, sensitive information, so you need to store it somewhere safe. That's just a whole nother bunch of code that I would have to write. So at this point, I started looking into Pulumi, and I was really curious to see how it could solve some of these issues that I was running into. So let's look at Pulumi and see how it actually works. So you start off by creating a Pulumi project, and that project will contain a program that is going to deploy your resources. And I think the main thing that sets Pulumi apart here is the ability to use general purpose programming languages to create that program, like C# or JavaScript or Go. And that really saves you from having to learn some proprietary language and allows you to reuse your existing skills. So for instance, in .NET, I program my infra as code in Pulumi in C#. I can use all of the language constructs I'm already familiar with, such as classes, loops, conditionals. And I can also use that broader .NET ecosystem, such as using NuGet packages to create reusable components. Now, the resources that I define in my program are managed by a resource provider. So if I define Azure resources, those are managed by a Microsoft Azure resource provider. If I want to deploy resources to AWS, that uses the AWS provider. And the nice thing about Pulumi is that there are really a lot of these resource providers. So here you can see a little screenshot that I took from the Pulumi registry page. It currently has 131 providers. And you can use a mix of them in your program. So for example, I can create a Kubernetes cluster that is running on AWS and also uses Auth0 for authorization. And I can use that all in a single deployment. Now, each time you deploy this program, you deploy to a specific stack. So a stack is an isolated, independently configurable instance of your program. And you can use these stacks to typically separate your environments, like having a separate dev, test, and prod environment. And then each of those stacks will have its own corresponding state. So this is the last deployed state, and Pulumi can use that state to make incremental updates to your environment. Now, this state needs to be stored somewhere, and you can use different type of backends for that. There's Pulumi's own servers called Pulumi Cloud, which I'll use in my demo, but you can also use Azure Blob Storage, Amazon S3, Google Cloud Storage, or just simply the local file system. So let's look at the demo and see how this actually works. All right, so Pulumi has the CLI that you can install, and you can use it to create projects amongst other things. So let me show you that I have that CLI installed right here on my local machine. And let's create a really simple first Pulumi application. So I'm going to name this Hello Pulumi, jump into that directory, and then I use that CLI with the command new to create a new project. And you can choose from a bunch of different project templates. I'm going to choose C# here, which will give me a really simple C# based Pulumi project. And it will ask me some questions about my new project. What do I want to call it? I will just hit enter to accept the default Hello Pulumi. Same goes for the description. And next we are asked for a stack name. So again, I'm just going to go with the default, which is a stack called dev, which will represent my development environment. All right, so now you can see MS Build's being called to compile that .NET program that's just being generated by Pulumi. And we can open that up in VS Code. So let me reuse this code window for that. And here we have our C# program. So if you look at the program file, you can see it only really has one dependency on Pulumi, which is to be expected. And then we have this Pulumi YAML file inside our project. And it contains our name and description, all the things we just gave as input. And also the runtime is set to .NET. So that's how Pulumi knows that it needs to compile a .NET application. Now, during the creation of the project, we've created a stack. We can also see the current list of stacks by executing Pulumi stack ls. You can see we have that dev stack here. We can now also create some additional stacks. So let's say I also want to create a production environment. Then we can create a prod stack. And now we have two, right? And you can see that prod is currently the selected one because I've created that one last. I don't want that, so I can use the Pulumi stack select command to switch that back to dev. All right, so let's open up the main program file now and look at the code. So not too much happening here yet. The program calls this deployment.run async method to execute the Pulumi deployment. And then we should add any resource that we want to deploy to this anonymous function here. And then what we see here at the bottom is that Pulumi deployment can also return output values. So for example, maybe you want to output a URL of where your application can be reached. So let's make this a little bit more interesting by adding some Azure resources. Now, if I want to add resources, I need to add the Azure resource provider to my project. And because I'm using .NET, I can simply do that by adding a NuGet package. So that package is called Pulumi.Azure Native. Now I'm using the Azure Native provider here. There's also an older Azure Classic provider, but it's highly recommended to use this newer native provider. Reason is that this native provider is generated automatically from the Azure Resource Manager APIs, and that means that it supports all of the Azure resources and is also up to date with all the latest resource features. So that's really nice. So to use that, let's add some using statements. And now we can start adding our first resource. So let's start by creating a resource group. So this is the way that you define resources in Pulumi. It's really simple. We just create a new instance of that resource group class, and we pass in a name for our resource group. And well, that's basically it. So inside this resource group, let's now create a storage account. Again, we can just create a new instance of storage account, give it a name. Only this time we also set some additional properties on that storage account, such as the SKU and the kind. Now, we wanted this storage account to be a child of the resource group. And we can do that by setting the resource group name of the storage account to resourcegroup.name. So this way, Pulumi knows that resource group is dependency of storage account. Now, if you look at the types, you can see that resource group name is of type input of string, and resource group.name is of type output of string. Now, inputs and outputs work a little bit like tasks in .NET, in that they are promises to some result in the future. And the reason why it works this way, and they're not just simply strings, is because the actual output values are not known before the resource has been deployed. And Pulumi can use those inputs and outputs to track dependencies between the resources and create a plan to deploy them in the right order. Now, another nice thing about Pulumi is the inclusion of some very useful utility functions. So let's say that we want this deployment to output the storage account key. Now, to get the storage account keys, we can simply use the provided list storage account keys function. If we invoke that function, it will output the storage account keys in this output parameter. And as inputs, again, we give it the resource group name, but now also the name of the storage account. And from this result, I can get my primary key, because the primary key will be the first key in that list. Now, how do I do that? Because this is an output and it's not the actual value yet. So for that, I can use this apply method. Apply takes a callback that's invoked on the actual value once it's become available. So in this case, once the account keys are available, I can simply take the first account key from that list, and then I return that as a secret. So this secret part, this output.createSecret, is very important because all input and output values are recorded as state and stored inside your state provider. So if there's any sensitive data in there, we definitely want to encrypt it. So this ensures that your secrets never appear as plain text in your state file. Now I'm using Pulumi Cloud as a state provider, and that automatically manages per stack encryption keys. But if you want something else, you can also plug in alternative encryption providers. For example, you could use Azure Key Vault to store your secrets. So now that we have this secret, we can set it as an output parameter. So here I simply assign that output primary storage key to primary storage key value in my dictionary. Now we are almost ready to deploy this. The last thing I need is to specify the Azure region I want to use. Now I could simply specify the region explicitly on each resource. There's a location property, as you can see here. And that's pretty useful, if you're deploying resources to multiple regions. But for now, I simply want to deploy all my resources in a single region. And to make that a bit easier, I can simply configure the region using a configuration option. And the syntax for that is you execute the command Pulumi config set, and then the specific key I like to set is Azure native location, and we're going to set that to West Europe. Now, when that command is executed, you can see that we now have this pulumi.dev.yaml file, which is a configuration file that's specific to my dev stack. And we can use this file to set all kinds of custom configuration settings that we can then access from code. And in this case, the Azure native location is automatically being read by that Azure native provider. So now we're ready to deploy this to Azure. There is actually a faster way to get to this point because there's also a Azure C# project template, while I use the more basic C# template to scaffold my project. But now you know what's required to deploy to Azure. By the way, if you are wondering how Pulumi knows which Azure subscription to use, Pulumi uses the Azure SDK under the hood to deploy the resources. So you can set the target subscription by simply logging in using the Azure CLA. So I'm already logged into Azure CLI on this machine, so I can start deploying now by running Pulumi up. So that will build my project, and in just a couple of seconds, it is going to show me basically the deployment plan. So what is it going to do? And in this case, it's going to create 3 resources. It's going to create my stack, and then in that stack, deploy a resource group, which will contain a storage account. And now it's up to me to give it the okay to go ahead, to decline that, or maybe look at some more details. So for now, we'll just go ahead. And then we'll jump over to my Azure portal, where if we refresh, we now see that new resource group showing up, RGLO Pulumi, and you can see that Pulumi automatically adds a suffix to my resource names to make sure they are unique. So that's a really nice feature to have automatically. So this is still deploying, so refresh it, that storage account is still deploying. So one of the things I really have to get used to is that the Azure portal won't show you any deployments, right? Usually when you do a bicep or ARM deployment, it will show up here on this deployment link. And that's because Pulumi isn't simply submitting an ARM template. Instead, it uses its own state to figure out exactly what changes have to be made, and then it uses the Resource Manager API to apply those changes directly. And in my experience, this results in way faster deployments than using ARM or Bicep directly. So let's see if the storage account is done. Yep, it's here. So now if we go back to Visual Studio Code, we can see that it has indeed finished, and it has a single output called the primary storage key. But we've marked that as a secret, so it won't show me the actual key. Now, those outputs are stored in the stack. So if I want to get to that output at a later time, I can do Pulumi stack output. And again, it will show me that output, but still encrypted. And then if I really want to know the value of the secret, I can add a flag for showing secrets, and then it will decrypt the secret and it will show it to me here. All right, let's go one step further and add a blob container to our storage account. So I'm going to add that. Then I'm going to do another Pulumi up. So now it detects that there's only one resource that needs to be added. So this deployment will be really quick. Let's go ahead with the deployment. Now, of course, the other way is true as well. If we remove any resources from the code, Pulumi will happily destroy those resources for you. And that can be very dangerous. So let me show you how to guard against that. So let me now comment out that blob container. Again, do Pulumi up. So we would expect Pulumi to delete a resource, but it will deny that. It will not do that. Now, the reason why it will not remove my blob container is because I've protected it using these custom resource options on line 24. So I'm setting protect to true. And this tells Pulumi that it's not allowed to delete the resource. We'll just get that error you just saw. Now, if we really want to delete a resource, we must first unprotect it by setting protect to false, deploy this, and then in a subsequential deployment, we can really remove the resource and it's gone. So now it's a two-step process, which is much safer. Now, of course, in the case of Azure, you can also use Azure Resource Logs to further protect Azure resources from accidental deletions. And that will also protect against users not using Pulumi and simply deleting resources directly from the portal. All right, now let's circle back to my original problem and look at some of the Pulumi code that I've written for that Azure Container Apps demo. So I'm going to open up another repo here. Close all of this stuff. Click away some of the dialogues and look at my Pulumi code. Let's start with our program CS here. So in this program, I mean, there are a lot of resources to deploy. So I use classes to add a bit of structure. So I have this infrastructure class, which deploys all of my basic infrastructure. So if we jump in there, you can see that we deploy a resource group, add a managed identity, create the Azure Container Apps environment itself. What else? I created Cosmos DB. I think there's a key vault in here somewhere. There's a SQL server. Here's that key vault. So all of my basic infrastructure. And then, so mail dev can be used to test sending emails. Mosquito is a lightweight MQTT broker. Then I deploy a bunch of Dapper components. And then basically for each of my application services, I have a separate class. So let's jump into this traffic control UI because that's the container app that needs to be protected using that easy auth feature. So what I do here first is I create the application registration, and that is going to be done using the Azure AD resource provider. Which you can see on top here. Now here I use the Pulumi Azure.native, which is the package we already saw, but now I'm also using another package called Pulumi.Azure AD. So that's going to set up the application registration. And then when I have that, I can create my container app, and it will use some of the resources that I've created for Azure AD. So inside this application registration, I do a bunch of things. I create the application registration, including all the permission scopes and stuff. I also created client secret here. Notice this additional secret outputs. So this tells Pulumi that, hey, you are going to get back a value, but that is sensitive information. So treat that as a secret. So that means that, again, it will be encrypted. And I store this application password. I store that in application password, which is a property of this class, and I store the application in the application property. Now, if you jump to the creation of the container app, Here you can see that I have some bunch to create a container app itself. But then we get to the secrets, and this container app needs to have access to that generated client secret. So I can simply reference that client secret value and store it as a secret to the Azure Container App. So this is really nice because this is the point where Bicep couldn't help me. This is where I combine something I created in Azure AD with something I create in Azure in a single script. And Pulumi will see that there's dependency there and that it needs to have, it needs to create the application password first, and then it can create the Azure Container App. The other nice thing is that client secret, that password, that is being securely stored inside the state of my stack. So the next time I deploy, I don't need to regenerate it. It can simply use that same value because it remembered what it is. Yeah, so all in all, I think this is a much nicer solution than using that mix of PowerShell and Bicep.
Well, Sander, thanks for showing us that. Really interesting stuff. But could you have also done that with Terraform? Could you use that the same way as Pulumi?
Yeah, so Terraform is very similar to Pulumi.
Okay.
And actually, some of my teams also use Terraform in production. It's also a great product. So the main thing I really never got into Terraform for my own personal projects is that it has this proprietary language that you need to learn, right? And I never really got into it to learn that. What I really, really like about Pulumi is that you can write your code in, well, like I just did, in C#, but you can also use Java, JavaScript code. There are a lot of languages that you can use. And well, that means that I can reuse my existing skills, right? Because I already know how to write C#. So that's a really big benefit to me for using Pulumi.
Yeah. And let's say that I have a team that is already using Bicep or Terraform or ARM templates.
Sure.
Would it be advisable for them to start using Pulumi or even migrate their scripts to Pulumi? Or what would your advice be to them?
Yeah, so I'm not sure if you're already into Terraform that you should switch. You're probably fine running Terraform. It's probably pretty difficult to create a business case to switch after you've gone through all the hassle of already setting it up. Yeah. If you are using Bicep and ARM, and you're running into the same kind of problems that I did, that you want to deploy resources not only to Azure, but also to other resource providers, then sure, making a switch to either Terraform or Pulumi could give you a lot of benefits. So the thing I found out after I manually migrated all my Bicep modules to ARM or to Pulumi is that Pulumi actually offers a very nice migration tool on their website where you can just put in an ARM template, and you can select your programming language, and it will output a Pulumi code. So that's really useful. Even if you're not doing infra as code at all right now, you can just go to the Azure portal, export a resource group to an ARM template, throw that ARM template in that converter, and out comes your Pulumi code. Yeah, so that's a real time saver. Yeah, and so we'll include that link in the description of the video.
We will. Okay, so thanks again for showing us this. It was great to see that. I hope everyone at home also enjoyed it. And if you like our channel, please subscribe to it. And then we'll see you at the next episode of dotnetFlix. See you later. Bye-bye.
Bye-bye.